Dear students, Happy New Year to all of you. Myself, Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. Welcome all of you in Wings of Physics. We will continue our chapter, that is structure of atom and nuclei, and this is the lecture number 3. And in this lecture, we will study about the energy of an electron which are revolving in around the nucleus. Okay, let us start. Derivation for energy of electron. Energy of an electron which is revolving around the nucleus. We know that in an atom, the nucleus is at the center and all positive charge, that is concentrate at the nucleus. An electron is revolving in a circular orbit around that nucleus. Means electron performs circular motion. It is having linear speed, and due to that linear speed, that electron is having kinetic energy. Okay. So we have to calculate its kinetic energy. Then here two charges are there. Positively charged nucleus and negatively charged electron. They are separated by some distance, and that is nothing but Rn distance. And if two charges are there, due to that electric field is there, due to that electric potential is there, and due to that electric potential energy is also there. And therefore total energy, that is the summation of kinetic energy and potential energy. Means we have to calculate the energy of an electron that is revolving around the nucleus, and that is nothing but the total energy of that revolving electron, that is nothing but the summation of kinetic energy and potential energy. Okay. Now we will calculate the kinetic energy first. After that we will calculate potential energy, and sum of these two energies, that is nothing but the total energy of the electron. And we will use the classical mechanics. Okay. Now first, according to the Bohr's first postulate, this electron revolves around the nucleus, and centripetal force required for the circular motion, that is nothing but the electrostatic force of attraction between this positively charged nucleus and negatively charged electron. And therefore, according to the first postulate, the centripetal force ME Vn square divided by Rn, this is the centripetal force, and electrostatic force of attraction, that is nothing but Ze square divided by 4 pi epsilon naught into Rn square, that is the Coulomb force. Now from this equation we can write Me Vn square, that is equal to, if we transfer this Rn here, then it becomes Ze square 4 pi epsilon naught Rn divided by Rn square, that one Rn that gets cancelled and Rn remains here. Now we know that the kinetic energy, that is nothing but the half Me Vn square, and if we multiply this term with half, at that time it becomes Ze square 8 pi epsilon naught Rn, and this is the equation 1, and that gives you the kinetic energy of this revolving electron around the nucleus. Okay. Now we will calculate the potential energy. Then first we have to calculate the formula for potential energy, that is electrostatic potential into charge. Charge, that is nothing but minus E, and number of electrons are Z. At that time that becomes minus Ze. This is the formula to calculate potential energy. Now potential energy, that is equal to the potential into minus ZE. Okay. Now first we have to calculate electrostatic potential, that we already studied in chapter electrostatics. How to calculate electrostatic potential or electric potential? We have to calculate electric potential here, that is at distance Rn from this charge, and therefore potential, that is equal to electric potential, that is equal to 1 by 4 pi epsilon naught, that is the constant. Then charge is plus E and distance is Rn, and this is the electrostatic potential at distance Rn from this charge. Okay. Now we have to multiply this electrostatic potential with minus ZE, and therefore potential energy becomes minus ZE square divided by 4 pi epsilon naught Rn. This is the equation number 2. That now we have to sum this equation 1 and equation 2, that is the total energy of that electron, and therefore total energy, it becomes ZE square divided by 8 pi epsilon naught Rn minus ZE square 4 pi epsilon naught Rn. Now the LCM of this equation, that is nothing but the 8 pi epsilon naught Rn, and here ZE square minus 2ZE square, that is nothing but minus ZE square. Okay, minus ZE square. Now we already studied that the derivation for the radius of the orbit Rn and the value of Rn. What is the value of Rn? Epsilon naught n square h square pi me ZE square. This is the derivation for radius. Now if we substitute, this is equation number 3 and this is equation number 4. Now if we substitute this equation 4 in equation 3, we can write the total energy, that is equal to minus ZE square 8 pi epsilon naught, that is 1 by Rn, it becomes pi me ZE square divided by epsilon naught n square h square. Now this pi, that gets cancelled, and derivation for total energy, I write here the derivation for total energy, that becomes total energy, then this pi, that gets cancelled, minus me z square e raised to 4 8 epsilon square n square h square. Okay. In your book, one printing mistake is there, and in that equation only epsilon naught is there, but epsilon naught instead of epsilon naught square is there. Do that correction in your book. Okay. Then total energy, that is denoted with the letter En. En, that is energy of electron in nth orbit, that is the minus me, then 8 epsilon naught square h square z square divided by me into e raised to 4 z square divided by n square. Now see the quantities in the bracket. Me, that is mass of electron, its value is 9.31 into 10 raised to minus 31 kilogram, mass of electron. Charge on electron 1.6 into 10 raised to minus 19 coulomb. Epsilon naught, that is also constant, permittivity of free space or vacuum, 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Then H, that is Planck's constant, 6.63 or 64 into 10 raised to minus 34 joule second. All are the constant. And if we substitute all the constants in this equation, we will get the value En, that is minus 13.6 into Z square divided by N square. Now, if the hydrogen atom is there, in hydrogen atom only one electron is there, and therefore Z, that is equal to 1, it becomes 1 by N square. Means for hydrogen atom, electron in the first orbit, that is the minus 13.6 divided by 1 square, that is nothing but minus 30.6 electron volt. Means suppose this is the nucleus, then this is the first orbit, and its energy is minus E1, that is equal to minus 13.6 electron volt, and this is the nucleus, and this is the energy for first orbit, and that is called as a ground state orbit, and that is the most stable orbit. Okay. Now for second orbit, suppose this is the second orbit, this is the second orbit, then its energy, that is E2 is its energy. Then substitute the formula, the E1, that is equal to minus 13.6 electron volt, E2, that is equal to minus 13.6 divided by N, that is equal to 2 square, that is equal to 4, and it becomes minus 3.4 electron volt. Means second orbit having energy minus 3.4 electron volt. Then third orbit, the third orbit, that is E3, that is equal to minus 13.6 divided by 9, that is equal to minus 1.51 electron volt. Third orbit having energy minus 1.51 electron volt. In similar manner, fourth orbit having energy minus 13.6 divided by 16, that is equal to minus 0.85 electron volt. Then next orbit, fifth orbit, that is having energy minus 13.6 divided by 25, that is nothing but minus 0.54 electron volt orbit. Then E6, that is equal to minus 13.6 divided by 36, that is nothing but minus 0.38 electron volt, and these are the energy of the electron in 1, 2, 3, 4, 5, 6 orbit respectively. And as the number of orbit goes on increasing, energy of the electron also goes on increasing. The ground state orbit, this orbit, that is called a stable orbit, but second orbit, third orbit, fourth orbit, fifth orbit, they are called as excited state or excited orbits. Okay, and electrons try to attain the ground state to stable, to remain this stable, means the electron are stable only in ground state orbit, and they are unstable in second orbit, third orbit, fourth orbit, fifth orbit, sixth orbit. And to attain the stability, it always try to jump from higher orbit to lower orbit. Understood? And due to that, the jumping of electron, different series forms, they are found out by different scientists, that is Lemon series, Balmer series, Paschen series, Brackett series, and Fund series. Okay, and 5 series are formed due to the transition of electron from higher orbit to lower orbit, and due to that a hydrogen spectrum is formed. Okay, I hope all of you understood this energy of electron in very well. Now we have to define the 3 different definition. First is the excitation energy of the electron. Second definition, that is binding energy of an electron, and third definition, that is the ionization energy of the electron. Now we will study these three different definitions. Now suppose this is the ground state N1, then this is second state, second orbit, third orbit, fourth orbit, fifth orbit and the infinity orbit N3, N4, N5. Okay. Now we know that the ground state energy of an electron or an electron which is revolving around the nucleus in the first orbit, its energy is minus 13.6 electron volt. In second state, this value is minus 3.4 electron volt. In third state, its value is minus 1.51 electron volt. In fourth state, it is minus 0.85 electron volt. In fifth state, it is 0.54 electron volt. In sixth state, it is the 0.38 electron volt and infinity. Now, first definition, that is excitation energy. Excitation energy of an electron. Now, the energy required for electron to go from ground state to this excited state. Suppose electron the energy required, हा इलेक्ट्रॉन जर आपल्याला ग्राउंड स्टेट मधून इथे न्यायचा असेल तो आपोआप जाईल का? नाही जाणार, कारण हा स्टेबल आहे. लोएस्ट ऑर्बिट मध्ये इलेक्ट्रॉन कसा आहे? स्टेबल आहे आणि त्याला जर आपल्याला इथे न्यायचं असेल तर वी हॅव टू सप्लाय एनर्जी. And what is that energy? That energy, that is nothing but excitation energy for first level. This is the energy, excitation energy for first level. That is nothing but the minus 3.4 minus 13.6 electron volt. Then the summation, that is nothing but minus 3.4 plus 13.6 and that is nothing but the 13.6 minus 3.4, that is 10.2 electron volt, and this is the first level excitation energy. This is the first level excitation energy. First level excitation energy of an electron, and its value is plus 10.2 electron volt. Means if we have to send the electron from this level to this level or from ground state to first excited state, at that time energy required, that is 10.2 electron volt, and that energy is called as excitation energy. Now if we have to transfer the electron from this state to the ground state to the second state, that is nothing but the minus 1.51 minus 13.6. Now it becomes the 13.6 minus 1.51. Then it becomes 9 0 to 12.09 electron volt. Then this is second level, the excitation energy. And in this manner, we can calculate the excitation energy for any orbit. For N4, for third level excitation energy, that is minus 0.85 minus 13.6 electron volt, that is third level, the excitation energy, and we can calculate the excitation energy for any level. Understood? But if a MCQ is asked, what is the minimum value of excitation energy? This is the minimum value of excitation energy for first level, as the number of orbit goes on increasing, excitation energy goes on increasing, and this is the minimum energy, minimum excitation energy. And therefore, what is the definition of excitation energy? The excitation energy, that is the energy required to transfer the electron from ground state to first excited state, or a ground state to excited state, that is nothing but the excitation energy of the electron. Now we have to define the binding energy. Understood? What is the concept of excitation energy? Now binding energy. Binding energy. Suppose here the nucleus, and we have to free the electron from this nucleus. Then for that purpose we have to supply energy. न्यूक्लियस पासून जर इलेक्ट्रॉन सुटा करायचा असेल तर आपल्याला त्याला एनर्जी प्रोव्हाइड करावी लागणार. मग आता याला हा जो ग्राउंड स्टेट मध्ये इलेक्ट्रॉन आहे त्याची एनर्जी आहे -13.6 इलेक्ट्रॉन व्होल्ट. अँड वी नो दॅट द बाइंडिंग एनर्जी, that is nothing but the minus the total energy. Then in ground state the electron is having energy -13.6 and minus 13.6 electron volt, that become plus 13.6 electron volt, means this is the energy required for the electron to set them free from the nucleus. इलेक्ट्रॉन पासून न्यूक्लियस पासून जर इलेक्ट्रॉन सुट्टा करायचा असेल तर आपल्याला त्याला एवढी एनर्जी सप्लाय करावी लागणार, कारण तो ग्राउंड स्टेट मध्ये फिरताना त्याची एनर्जी ही एवढी आहे आणि त्याला जर फ्री करायचा असेल तर एवढी एनर्जी आपल्याला सप्लाय करावी लागणार. आणि म्हणून दिस इज द बाइंडिंग एनर्जी, that is nothing but plus 13.6 electron volt. Now we have to study the definition of a ionization energy. What is the ionization energy? Third definition, that is ionization energy. Ionization energy. आता बघा आपल्याला ह्या ॲटम पासून इलेक्ट्रॉन फ्री करायचा आहे. मग ॲटम पासून जर इलेक्ट्रॉन फ्री करायचा असेल तर ग्राउंड स्टेटला एवढी एनर्जी आहे, आणि जर त्याला याच्यापासून फ्री करायचं असेल तर ॲटम पासून फ्री करायचं असेल तर आपल्याला काय करावं लागेल, ई इन्फिनिटी मायनस E1. आता ई इन्फिनिटी किती तर आपल्याला माहिती आहे याचा फॉर्म्युला -13.6 डिवाइडेड बाय द इन्फिनिटी स्क्वेअर मायनस E1, that is nothing but -13.6 divided by the 1 square here, that is 1 by infinity, that is nothing but 0. Therefore -13.6 it becomes 1 by infinity 0, therefore this term becomes 0, and this minus that become plus 13.6 electron volt. म्हणजे ह्या ग्राउंड स्टेट पासून जर इथपर्यंत इलेक्ट्रॉन नेऊन त्याला जर फ्री करायचं असेल, इलेक्ट्रॉन जर ॲटम पासून फ्री झाला तर त्याच्यापासून काय तयार होतो, आयन तयार होतो. आणि म्हणून ॲटम पासून इलेक्ट्रॉन फ्री करायचा असेल तर आपल्याला एवढी एनर्जी सप्लाय करावी लागेल, आणि त्यालाच आपण म्हणणार आहे आयोनायझेशन एनर्जी. कारण ॲटम मधून इलेक्ट्रॉन निघून गेला की तिथं आयन तयार होतो, आणि म्हणून त्या एनर्जीचं नाव काय आहे, आयोनायझेशन एनर्जी. Though value of binding energy and ionization energy is same, but concepts are different. This is the energy required to free the electron from the nucleus, and that is this energy, and this is the energy required for the electron to set them free from the atom. Atom पासून सुटा करायला, इलेक्ट्रॉन सुटा करायला जी एनर्जी लागणार आहे तिला कोणती एनर्जी म्हणायचं, आयोनायझेशन एनर्जी. आणि न्यूक्लियस पासून सुटा करायला जी एनर्जी लागणार आहे तिला म्हणायचं बाइंडिंग एनर्जी. अँड दिस इज द डिफरन्स बिटवीन these two concepts. Okay, I hope all of you understood all these concepts very well. If you like this video, then like, share with your friends, and subscribe my channel, and also press the bell icon so that you will get notified about my new upcoming videos. Thank you very much.
Oh,